Hello.
Hello. Yes, I don't know what's happening with my connection, but now I think it's.
Okay, so basically today I will try to discuss about the flood subsibility, mainly other part of the flood subsibility which is not completed yet. And after that, we are just developing the flood risk zone, where we find out the high risk, low risk, middle or medium risks about these things. We try to complete. And today's session, inshallah, we try to complete the full project of the flood risks. Okay. So let's go. Just I simply share my screen. Okay, can you see my screen now? Is it visible?
Not yet. Yes.
Okay, so let's go. So previous class, I also some review again Evan about the previous class. So mainly in previous class, we try to discuss about the
Why you did mistake the the shape file that I share with you? Okay, no problem. Let's go even with this. No
Okay, no problem.
problem.
After finishing that, we try to use this shape file, and then further we are use it. No problem. Okay, so let's go. Okay. So previous class, I try to discuss about that mainly how we can easily get the this type of things, mainly water data. You can see I already added this type of layer. So here you can see it's a this is your boundary area, and further we can get the water. Mainly in this time we are using at the global surface water data, and from here we find out the permanent water body. We can get this type of things is the permanent water body, and from here we are just calculated the distance from water, and from the recalculated distance without parameter of water, as well as we also make the elevation. Okay, so in this time we try to discuss about the other parameter. Okay, and then we are just use this type of parameter to make the flood hazard map. So let's go. Okay, so elevation is already done. In this time we talk about that topographic position index. Okay, so it's called the TPI. Okay, TPI, mainly it's called in full form is the topographic position index. So basically this TPI, it's very useful. Mainly it's a very useful index to identify for the flood hazard zone. Okay, so in topographic position index, first of all, we have to know about
Identify what?
it is a TPI, topographic position index. Okay, so topographic position index. So I simply show you the from the Google. Just a minute. I simply start from the Google. Okay, so here you can see some information about that topographic position index value. Okay, so you can get. Okay, so just I simply open the index first formula. So I want to show you the formula. What's the formula I want to use for that topographic position index? So just I simply open these things. Okay. So basically, there are a lot of software we can easily use to calculate the topographic position index. So mainly in this time, they are describe about the topographic position index or TPI. So mainly you can see what is TPI. Mainly the topographic position index help us distinguish topographic features such as hilltop, valley bottom, export ridge, floodplain, upper or lower slope. We can easily distinguish using the TPI, mainly topographic position index. It is calculated by comparing the elevation of each pixel to its surrounding neighbor. The number of neighbors you compare it to mainly makes the big difference. 5 into 5, 1 into this type of things. So here you can see that TPI, 0 or non-zero value flat or near continuous slope. TPI large positive value. Its identify about the central pixel is much higher than surrounding areas such as hilly region. TPI large negative value. When I can get the large negative value, it's mainly bottom of valleys or gully. Okay, so basically in this time this index is very helpful to identify the flood zone or flood rig zone. Where is the high flood, where is the low flood? We can easily get it from the TPI. And when you can get this type of value, suppose TPI, when I can get the 0 or near to the 0, this value indicating the continuous slope. Okay, continuous slope. When I can get the TPI value, suppose large positive value, it can be ridge area or hill or hilly region. And when I can get the TPI value, mainly large negative value, it means about that valley or gully for the position of the different types of terrain on the surface. So in this time, we calculate the TPI and then find out for my study area, what is the condition for the TPI. So basically, in this time, they are calculated the TPI using mainly GDAL in R programming language. In this software, you can see this. They are used at the GDAL in R, but in this time, we are apply the Google Earth Engine platform without GDAL in R. But they calculated these things from the GDAL. Okay. So let me check. I think some networking issue. Okay, so here you can see in this time they are used at the GDAL in R, but in this time we are not use the GDAL. We try to use here the Google Earth Engine platform and then calculated the TPI, mainly topographic position index. So let's go TPI. So for calculating the TPI, we just take a variable. Suppose I put the variable name is the TPI. We can put any variable name, and further I call the elevation. I already make the elevation. Simply copy the elevation. This elevation I just simply with elevation.
So,
With elevation, and in this time I need to find out the focal mean. So in this time you can say what is the focal mean. I just simply search on the Google and search there focal mean. So just you can see the focal mean function. So basically, you can see morphological mean. Suppose mainly focal mean, it applies a morphological mean filtered to each band of an image. So in this time, I want to calculate the each band of elevation, each pixel. Okay. So in this time, I put the focal mean. Focal mean mainly it applies a morphological mean. Okay, mainly it filtered to each band of an image using a named or custom kernel. So in this time I just use here the focal mean, and you can see the first is the radius mainly this image to which to apply to the operation. It's the radius, mainly it's the integer value we can put in here, the integer value the radius to kernel to use. So default is the 1.5, this is the radius. So in this time, I simply use the focal mean. I want to apply it as a morphological mean filter. Simply copy and then use here the dot product and paste here this function focal mean. I put the radius, suppose 5 meter radius as a focal mean, and further I just simply use here the suppose further we just put here suppose rename, put the rename as a TPI. And now I want to add the layer about the TPI. Suppose map dot add layer and call the TPI. Simply copy and paste. Now click run. In this time it added the TPI. mainly topographic position index. And topographic position index, from where we can easily get this type of things. Suppose you can see when I can get the zero or near to the zero value, this value indicating the continuous slope. Okay, flat or continuous slope. Or TPI, when I can get the large value, large positive value, it's indicating the hill or high elevation region. And when I get the TPI value, it's the large negative value, it's indicating the bottom or valley or gully. Okay, so now let's check what we can get from here. It loaded the layer for the TPI. Topographic position index. You just open this layer only. Okay, you can get this type of things. So I add the color. Suppose click on here, and then simply stressed 98%. And then further just click on the plate. I want to show. In this time I can get the negative and also get the some positive value. You can see it will be still negative. So basically here I can get the negative, large negative value. It's indicating the bottom or valley or gully region. Okay, bottom can be bottom of valley or gully. So I want to use suppose this type of color for the low value for the bottom or gully. Suppose I want to use here this type of color or blue color, or you can use any color, no problem. Greater than things, I want to use this type of color. Greater than this, I want to use this type of color. Okay, you can use any color, no problem. And further I use here the and I want for the high elevation or hill region or high positive value. Suppose I want to use here this type of red color. Okay, it identify the hilly region or high elevation, and this type of things about the low region, mainly hilly or kali. Okay, so now apply that. So now let's check the result about the TPI for your study area. It's working.
I I don't understand the voice. They soon.
Okay, can you hear me now?
Can you hear me?
Let me check. Hello. Okay, okay, just a minute. Let me check. I think some networking issue. Yeah. Okay, just I reload my system. Okay, hello. Now can you hear me?
Yeah, now I can hear you.
Okay, okay. So let's go. Yeah. So in this time here you can see I just apply this TPI. So mainly in this time we can get this type of things. Okay, and this region is mainly totally flat, or we can get the some this type of things. You can see it show about the high elevation. Mainly it's the positive value of TPI. Suppose I click on the inspector tab and click on here. Suppose click on here, I can get what is the value about the TPI. You can see the TPI value is that positive value I can get. Okay, so in this time here you can see this type of positive value, large positive value, it can be ridge or hill or hilly region. The central pixel is much higher than surrounding areas. Okay, so it is the higher than other pixel. So it is the high. This type of things about the high position of the TPI. So in this time, it's the high position. So now this type of region is not very high. It's the very low susceptibility of flood risks or low risks about the flood, because this topographic is the high, or this type of things is the high elevation, because this TPI value or topographic position value is the positive. But further, suppose I simply click on this type of things. Now check what is the value about this type of color. In this time we can get the negative, or we can see very not very much, very low positive value we can get in here. So in this time it's the very low positive value. So this type of region is not much higher, or this elevation is not higher. So it's the totally such as we can say that it's a low or flat. Okay, in this time you can see it's the zero or near to the zero. Okay, flat or near the continuous slope. Okay, so in this time four is the near to the zero, not a mass high value. So that's why this type of pixel you can get here. You can see it show the, you can get the negative. Okay, so mainly when I can get the negative value, what is that? When I can get the negative value, it can be bottom or valley. You can see large negative value. Okay, suppose most large negative value, it can be the bottom of valley or gully. So this type of thing, suppose this type of large negative value, this type of negative pixel value, it's identify the high flood susceptibility. Okay, this type of negative value or near to the zero. But this type of high positive value of the topographic index, suppose click on here, I can get this type of things. You can see the 395 TPI value. So this type of value is the low flood risk about that. Okay, so it's a TPI. Further, we also make the classification and then make the flood risks again. So we put the TPI. Okay, done. TPI is done. So it's the topographic position index. Mainly, I'll send you the link. You also try to read that. Then you can get a lot of information when the zero or non-zero, large positive value, large negative value. Okay, then you can easily get the idea about the TPI or topographic position index. Okay, after doing these things, we talk about that. Suppose we talk about the suppose NDVI. Okay, so basically NDVI mainly vegetation. Vegetation is another important factor for flood. Okay, vegetation and non-vegetation, this type of things is very important for the flood. So in this time I talk about the vegetation and then try to make the map for the vegetation. Suppose I just use there the NDVI and I want to make the vegetation using Landsat 8 satellite imagery. So okay, there is no lands. Okay, you can say I already imported the Landsat 8 imagery. For that, make the land use land cover and also make the NDVI. Okay, so in this time, we are just use this image collection and then make the NDVI. So let's go. We just try to make the NDVI map using LST. So for doing these things, just take a variable. Suppose image and I call my image collection. Basically, you can see this is my image collection. It is stored in this variable L8. Simply copy the L8 and paste here. So now I want to use here the filter bounds with my study area. Study area mainly your boundary shapefile. In this time, my boundary shapefile name is the ROI. So just I put here that ROI, and then further use here the filter date function. Suppose I want to observe for 2023. Suppose 1st January from year of 2023 December 31. And further I just use here the filter metadata. Mainly I choose the cloud cover. Suppose cloud cover less than suppose 1. Okay, and then I create the median composite. So this is my satellite image. I just simply click with my study area, suppose RY. So now I want to display this satellite image. So just add a layer, add layer, this image and click to the run. In this time it create the another layer. Get loaded. Okay, so I think okay, so let me check. So I need to okay, so just simply click on here. I take my image collection of Landsat. I want to work for suppose Landsat 8 image collection. Top of atmospheric. And I want to simply copy these things from here. Then further, I just change it. I'll put the layer name. Suppose it's a API. I think okay, I need to increase the cloud cover. Suppose cloud cover. Okay, make the mistake in here. Cloud cover. CO. Okay, COVER. Now let's check. I can get this type of image. Okay, but you can see in this time it not fill up the full boundary. Okay, it just show. Okay, so other things is not showing. So for doing these things, we have to increase this value. Suppose I increase 8. Suppose less than 10%. And now let's check, because less than 1% image is not available for some study, some area of this study region. Now let's check again. So now it almost cover, but only for these things, and these things is not cover. Okay, basically in this time for this region and for this region, less than 10% image is not available. So just I simply also increase, suppose less than 50%, and now check again. Network issue. It working. Okay, I think we will need to also increase the cloud cover level. So just increasing, suppose 20%. Now let's check. Almost is not finished. So let me check about the 30%. So basically, some time it's not fully covered because this region is not available for that. 10% is not available, 1% is not available. Then we have to increase this cloud cover level and then check. Oh my god. So some region. So let me check about that. Suppose 35. Okay, now fully fill up, you can see. And I simply click on here and further I add here that band composite. Suppose I add here the red band B4, then green band B3, and blue band B2. And custom stretch 98%. That apply. Now it show about the true color composite. So just working. So now apply. Okay, so now we can get this type of image. And now I want to make the NDVI. Mainly, I want to extract the vegetation map from here. So for that, just take a variable. Suppose just I put a variable name, suppose NDVI, and I call this image test here and use a function normalized difference and put here mainly two things. One is the near infrared band. This name is that, you can check it from the name. You can see for the band 5 name is that near infrared band, and red band. Okay, band 5 and band 4. Just put here the band 5 and then put here that band 4. So it's called, I put as a rename as the NDVI. So it's my NDVI. Okay, done. I want to show the maps. So just use here map dot add layer NDVI NDVI, and further I add the color. So just put here that mean. Suppose I put here the mean -1 and max up to +1, and set the plated as a list. So just put here the color plated such as suppose blue, white. The layer name, it's my NDVI. So now click the run. Now it added the NDVI map. And further we also need to calculate it that NDWI. For the NDWI, we are just use the same approach. Just take a variable, suppose NDWI, then call this image, put here normalized difference, and copy and paste here. Normalized difference between two band for NDWI. It's a green and near infrared band. Mainly, it's called the B3 green and near infrared band V5. Okay, and further I just put this rename. Use that dot rename as NDWI. Okay, so now further, if you want, you can also display this map about the NDWI. So just use here map dot add layer and call the NDWI So just put here, suppose mean, put here that 1, sorry, -1, and max, suppose +1, and inside the plated function, plated, I make the list about the plated. Suppose I put the color for the NWI, suppose red, then suppose white, and for what I use at the blue, and put the layer name, it's NDWI. So now click run. So now we calculate all of those things, NDV and NWI, other things. So now in this time we have to set the score. Okay, and it's very important for set the score. And using this score we are just make the flood risk. In this time you can see basically this our factor such as NDWI, NDVI, then TPI, elevation, distance from water. Okay, so in this time we set here the total 5 factor. If you want you can also add here the more other factor, mainly who is influence on the on the flood, such as precipitation. It's very important for flood. Okay, suppose precipitation, if you want you can also consider. Suppose I want to add the another, suppose precipitation. Okay, so for that we have to use the precipitation data set. So just I simply search here charts. Okay, so basically you can see these are charts. It's one kind of satellite. It's provide the uh, precipitation data set we can get from the chart satellite image. We can get the precipitation data set, such as here you can see I simply click on here. So basically in this time this is the charts painted climate hazard group infrared precipitation with station data. We can easily get from here the precipitation data using these satellite images, and we can easily get here the high precipitation, low precipitation, and we can get the data set from 1981 to present time. Okay, we can easily get this data set. So in this time if you want you can also work with the precipitation, because precipitation is also more influence on the flood. Okay, so just I simply import.
So this is the precipitation for more years ago now,
Yes.
not for now.
Yeah, present
But
present
how?
time we can also get from, you can see
That's
it will be start from the 1981 to present time, suppose
today.
today. Yeah,
Today.
yes, for the
Ah,
now we
okay,
can see.
okay, okay.
So we can get that
I
under
get it.
when it's updating, no problem. We can see now
Okay.
it available for the 26th December, okay, 2023, but it's updating.
So after that, this is the precipitation for.
Yeah. And the global data set we can get from the precipitation, and this data set mainly 30 years global rainfall data, so we can easily get from here. And resolution satellite imagery, and it also including with in situ station data. Okay, to create graded rainfall time series for trend analysis of the seasonal drought monitoring, it also used for that SIEPS data set. So in this time we are also consider this SIEPS data set. Mainly we can get the two version, one is the painted, another is the daily. Okay, so in this time we painted mainly 5 days average data set, and daily mainly daily data set every single day we can get. So in this time we are considered the 1 year painted data set. So just I use it and then make the precipitation for your study area, and then further also use it for the make the ASP method, mainly analytical hierarchical method. We also use it. So let's go. Just I simply import the data set chips. Suppose I put this name is that, I put the name chips. Okay, so now this chip data set I want to show for my study area. So you can see it my NWI, NDVI, it's my TPI, elevation, distance, distance from water. So all of those we cleared. And this time we talk about the chaps. For the chaps, we are just make the precipitation. Precipitation. So just take a variable. Suppose precipitation. I put any variable name and then call this image collection. So basically this is my image collection charts. I simply copy this variable name and then paste here. That just use here filter date. Suppose I want to talk about for 1 year, 2023, 1st January. from 2023 December, suppose 31, and I simply select this specific band of precipitation. This band name, you can see this band name is that precipitation. Simply copy this band name and use it, and I calculated the average precipitation for 1 year. Okay, and it clip with my study area, which is ry. It's my shapefile variable name. So now display this result. So just use the same function map.add layer, map.add layer, and call the precipitation. Simply copy and paste and click run. So now we can get the precipitation map added in here for my study area. So we can get this type of things because I did not add any color. So I'm going to add the color. Click on here. Here you can see. Click on the custom state 98%. And further we can get, you can see it show the low precipitation 12 millimeter and high 35 millimeter for this study area. So I want to add the color. Suppose for the low precipitation, I want to show this type of red color. Then get it, then I show suppose this type of yellow color. Get it, then I show suppose this type of green color. Get it, then suppose I want to use here this type of blue color. Okay, for water. So now I apply. So now this color is set in my map, and here I can get this type of precipitation map for my study area. Okay, so here you can see mainly this type of region is the high precipitation. Okay, this type of region show about the low precipitation, mainly 12 millimeter or less than 12 millimeter we can get from here, and it show about the high precipitation, and also we can get the this type of the low precipitation. You can see the color about that. So further I simply import this color and then further copy from here, and then simply and put this layer name is the precipitation. So these are precipitation map, mainly rainfall map we can get from here. Okay. Okay, so after creating all of those factor in this time, we have to add the score. Okay, so in this time, score how I can add for each factor. Suppose here you can see the distance from water, elevation, TPI, NDVI, NWI, precipitation. So all of those factor, I want to add the score. Score mainly in this time, I just create the total 5 class. Suppose for this precipitation, I create the total 5 class about the precipitation. From the low class, suppose low value of precipitation, it's one kind of class. Then sorry, very low, low, medium, high, very high. Total 5 class. So I write the class name. Suppose in this time we calculate about that score for each factor. Okay? Each factor we calculated the score. So in this time, we set here, suppose very low, then low, then very low, low, medium, then high, and very high. In this time, for the score, we set here the very low susceptibility, low, medium, high, and very high susceptibility. For very low, we set the value for 1. Suppose low, we set the value for suppose 2. Medium, we set the value for 3. High, we set the value for 4. And very high, we set the value for 5. Okay, so 5 is the very high, then high, medium, low, very low. We set the score, and now all of those factors, suppose NDWI, NDVI, precipitation, TPI, elevation, distance from water. So all of those factor we just make total 5 class. Okay, and then when I can get the very low class, low, medium, high, very high. So this type of 5 class we generate for each factor. Okay, so let's go how we can easily create this type of factor. First of all, we try to discuss about the distance. Suppose here you can see I just simply open this layer. Yeah, so yeah, yeah. So in this time we talk about this. Suppose in this time I want to work for this layer distance without permanent water. We find out that score. Okay, so simply click on here. Here you can check what is the high value, low value about that. Suppose it's at 98%. We can get the distance from here. You can see 0.5 to 23.65. Okay, so in this time we have to generate the total 5 class between this range. So for doing these things in this time, I just take a variable. First of all, suppose a distance score. We make the total 5 class. So just take a variable. Suppose uh, distance score. Okay, and I want to calculate the distance score from this map. Okay, and this map is already I create and stored it in a one variable. What is the variable? You can see we calculate this map from, yeah, yeah. So these things simply copy and then paste here, and now I just use a thing. Suppose I use a function and make the class. Suppose only distance, mainly when distance is high. Suppose from the water body distance is the high distance, so it show as a very low subsibility. Okay, suppose from distance is high, okay, then flood subsibility or flood risk is very low. So in this time I just put here that distance greater than, suppose I put the distance greater than, in this time I put the distance greater than, in this time I can get from here suppose custom 100% I can go, I can get from here suppose 24. Okay, suppose I put here the distance greater than 24. Okay, distance greater than 24, I make a one class and it's my high distance, and I set it as a class 1. Okay, and what is the 1? 1 is very low. Okay, so all of those distance greater than 24, I set the class 1. 1 is very low. So now I take the second class. So for that, use the same things. Suppose, suppose in this time, I simply make some range about that. Suppose I just take a higher function again, higher. Uh, only distance. Suppose greater than. In this time, suppose I just make the some class.
So
Yeah.
when you say about the distance, what do you mean? It means the distance from where to where?
Water.
The distance is the dipping, or the distance just from the distance between the
Horizontal. Border. Border.
border. It
Yes.
means from one district to another district.
No, it's the border of water. Border of
The
water.
okay, the border of water and the area that
Surface area. Water without surface area.
it means that if you have this area and we need to know the distance from this area to border.
Yes.
If the border is near or not.
Yeah. Then this time here you can see this is the water, and here we can get. Suppose I click on here and check it. Suppose click on here, click on this here. So now I can get this result, you can get the distance, you can see 0.9. So it's very close to the water, 0.9. So when I click on the suppose any kind of this type of red color, so now I can see what the distance we can get from here. We can get the distance 88. Okay, so this 88 is not it's very low substability of the flood. Okay, because this distance is far from this water body. Okay, but when I click on here this type of region, we can get the distance from water very close to the water. You can see 0.3 meter, or also click on here, we can get these things from here. You can see 4.8 meter, so it's very close to the water. So that's why this in this time we make the one class, all of those distance greater than 24, we make the one. And what is the one is the very low subsidiarity, many very low risks, greater than 24, all of those area from the water body. Okay, so now take the another thing, suppose in this time, and this type of value is not fixed for all of those region. So this is another problem. So when you want to work for a specific boundary, you have to find out and you have to classify it. Suppose total 5 class we classified for one factor. Suppose this region you can find out the 24, but other reason we did not find the 24, so it's not constant, it's a changeable value. Okay, so uh in this time I check the another, suppose I make the distance, suppose in this time we talk about the distance, suppose greater than 24. I want to make the another distance, suppose, okay, just I cite in write some note in here. Suppose one class is that greater than, suppose 24. Okay, I want to make the second class, suppose 20, greater than 20 but less than suppose less than 24. Okay, I make the another distance. Suppose I take the another thing, suppose okay, I write in here one by one, comma sign. Suppose second third class I want to make for that greater than, suppose greater than 10, greater than 10, and suppose less than 15. Another class I will put in here. Suppose I make the another class about that, suppose greater than 5, suppose less than 10. Okay, and finally create the another class, suppose less than all of those area less than 5. Then this time suppose I just follow that, suppose I just put here the greater than, suppose 20, greater than 20 distance, and put here the and function, and only distance, suppose less than equal, suppose 24. Okay, so I make this, it's a another class, suppose 2. 2 is the, suppose low. Okay, very low, then medium. Suppose I take the another about that, just okay, just I simply copy the same line of code and use one by one, it also better. Suppose fire, and also put here the fire. So in this time, suppose third number, I just put here the greater than, suppose 10, less than, suppose 15. I make the another class about that. Suppose then put here the greater than uh, suppose 5, and less than equal, suppose 10. Okay, so 1 2 3 4, and finally suppose all of those things from less than equal, suppose 5. So just I simply put here that it's not need, I simply remove that. So just put here only distance less than equal, suppose 5. Okay, so in this time what happened, I just simply put here the 1 2, then it's a 3, it's 3, then 4, and then 5. In this time we can see again, when I can get the, suppose less than equal 5, so 5 meter distance, when I can get from the water body, I consider it's a very high subsidiarity, because 5 is the very high I consider. And then when I can get the 5 to 10, it's the high. 10 to 15, I consider it as a medium. 20 to 24, I consider as a low. And 20 greater than 24, I consider as a very low subsidiarity or very low risk. So now it's create the total 5 class. Okay, for my distance, according my distance. So I create the total 5 class. So now I want to show this map. Suppose I want to show this map depending on the score of the distance. So just use your map dot add layer, and further call the distance score, and I put here the suppose mean is the class number 1, and max class number 5, because total 5 class 1 2 3 4 5. And further suppose I just click to the run. In this time you can see it create the 5 class, and where I can get the 1 is very low subsidiarity, and where I find out the 2, it is the low, 3 is the medium, 4 is the high, and 5 is the very high, because it's very near to the water, less than 5. So now we show the layer, then we can easily get this idea how it will work. Let me open. Okay. Okay. So in this time we can get this type of layer, you can see. So it also better when I have to add the color. Okay, so then it also better. We can easily identify about this. In this time, suppose I click on here. Suppose very low subsidiarity, very low risk. Suppose very low risk, I have to show as a red color. It's a very low risk. Okay. Then low, suppose I have to show low is this type of yellow color. Sorry, very low, I show as a red color. Then low, suppose this type of yellow color. Then suppose after the very low, we have to use here medium. Suppose medium, I have to show this type of green color. Then medium, we show the high and to show this type of paste color. And very low, suppose I show this type of green color. Oh, sorry, blue color. Okay, it is a very low, sorry, very high subsidiarity. Okay, so this color identify very low very low risks. This color identify about that low risks. It is the medium risks. It show about the high risks, and it show the very high risks. So now we apply. So now it loaded. Okay, so now I can see. In this time, we can get this type of map. So in this time, this type of blue color, mainly this type of region, where we can get the blue color. This region is very high flood risks. Okay, and this type of region is the high, then it's medium, and it's the mainly low, and it's the very low. This type of color. Okay, so this type of, you can see this type of red color identify about the very low risks. So in this time, we are just consider only for the one factor, only for the distance. But we have to create all of those other factors also. Precipitation, NDWI, NDVI, TPI, elevation. We have to create one by one. Further, we are just make the overlay. Then we can easily identify about that. But in this time, this result show only for the distance from water. Distance from water flood susceptibility mapping we can get. So just I import that color, and further simply copy and paste here. Just I remove that, I paste here. paste. And further, I just give a variable name. Suppose I put this variable name is a distance hazard score. Okay. So now we can get the distance hazard score. Okay. Further, we have to talk about the suppose elevation. Okay. We have to make total 5 class of elevation. Okay. So let's go how we can easily create the elevation score and then make the elevation score map depending on the flood risk score. So now talk about the elevation score. Elevation, elevation score. So first of all, I try to open the elevation map. I already create the elevation map. Here you can see the elevation map. Okay, so this is our elevation map. Okay, so now this elevation map, I want to make total 5 class. Okay, so
So this here the blue color is what? Is
it's the low elevation,
high?
and this type of red line is the high elevation. It's the high elevation. It's about the low elevation, about this type of blue color. You can easily check it. Yeah,
Elevation it means what? It means
elevation from sea level. Suppose I click on here, you can see I can get the height from the flat surface, height from the sea level, mainly of flat region. We can
elevation it means the water, the level of water.
level of water height from the level of water height.
Yeah, but in from I don't know, but in our country, the it's a difference. Here we have elevation is high because we had a lot of floods anytime. But here I saw that yeah it is low. So
So in this time, this is the data from
your
the
left,
satellite
yes, in your
images. Yeah.
left, yeah. The blue color normally we need it should be the high level because in our country this is the region that we had a lot of floods anytime.
Yeah,
So,
so
but
it's a low
I'm
elevation.
surprised to see that it is.
Okay, so in this time you can see it show about that low elevation, and here we can get the different types of stream. Stream mainly you can see it's a river or other things you can get from here. You can see it's a stream or river line or different.
If we want to present this to say that this is elevation of water in the earth, anybody cannot accept because everybody knows that this kind of the left is the place that we had many time we had floods anytime.
Yeah. So in this time, this type of region is show about the high elevation because I think here we can get the some. Okay, so is there any hill or other things available or not? And this data set is provided from that NASA SRTM satellite imagery. Here you can see the elevation, and we can get this type region. Suppose click on here, we can get what type of elevation from here.
Because if you see like this, anybody cannot believe you. Because even in December, we had a lot of floods in this region.
This region,
So
red color region.
yeah, the left region. We had a lot of we had food
But in this
this.
time, it show about
So,
that
but
you can
I don't
see.
know this precipitation. It's just for now, or just for now, or it will change anytime.
Yeah. But
Yeah,
in
this is the question. Right? It will change anytime, or it's like this.
Okay, let me check. Yeah, let me check. Let me check. I think some mistake in our color gradient. So now, we can get. You can see okay, almost flat region. You can get here. Okay, suppose it's 98 100%, and then apply.
So I want to understand if this precipitation can change anytime.
Yeah, precipitation can be changed anytime. No problem.
Okay.
And in
So maybe for now, the precipitation is here.
yes, yes. So for that, it also occurred the flood in this area. Even it is a high region, but it also show the okay. In this time we can get this type of region. You can see it show this is the elevation 2691 meter. Suppose click on here, check it for the elevation. You can see it show about that 3108 meter. Let's click on here. So is there any hill or any heat rock region is available or not? Or any hilly region? I think it's a
So if it will change, yeah, if it will change, yeah, it's if the data will change anytime, yeah, it's okay.
yeah. I think it's a rock or rock, this type of rock or hilly region rock we can get from here. Okay, so let's go. Yeah, elevation. So now we just make the class of elevation score and then make the classified. So same process we try to apply in here. Total 5 class we generate in here. Okay. So in this time, okay, just I simply copy the same code because I need to use it. I simply change the variable name. So in this time, I want to make the elevation score. So just I simply put here that suppose elevation score, and I want to calculate the elevation score from elevation dataset, mainly this map. So here I can say I already create the elevation map. Elevation mainly this or elevation. Simply copy and then further just I simply change it here elevation, and from this elevation I not consider the distance. Okay, okay, so for that I am in this time we cannot include the distance in this time for the elevation. So just okay, just I remove that, and elevation update with elevation will be update marks with distance. So I already make the distance map. Distance of water. In this time, we are not considered the water distance in this elevation. Okay. So just I put the water distance not equal to 0. Okay. And then I just put my class. Suppose first of all, higher the elevation, where the elevation mainly is elevation. Simply copy and paste here. Where the elevation is greater than in this time I simply put here the gt greater than, and then check about the elevation value. So here we can get suppose elevation, you can simply open and clear the state 98%. So here I can get this type of value for this study area. We can get this it show the 508 meter and 3008 meter. So basically this 3008 meter, so just I simply use here suppose 3088. Okay, so this is the mainly your it's very low subsibility. So this type of elevation, it's very low subsibility of the flood. So further I simply use here the one score. So just I put here that let's say 1. Okay, and further I just make the class, other class. So just use it the where function. In this time I just make the some class. Suppose randomly I put the class. Suppose one class for greater than 3088. Suppose then I want to make the class for low. I want to make this class, suppose 1000. Sorry, I make the class for suppose 2000, from 2000, from 3000. Suppose put the, suppose then put here that 1000 to 1000. Then suppose put here that it to 1000, and all of those suppose 5000. So I simply put this class, 5 class, 1 2 3 4 5. So in this time I get all of those elevation which is the greater than 3088 meter. I put the one mainly very low susceptibility. Okay, then I consider it's a low, then it's medium, it's high, and less than 500 elevation, it's very very low, sorry, very high risk of flood I consider in this time. And now I want to put this type of things in here one by one. So first of all, where I put the elevation where suppose where greater than 2000, and elevation less than equal 3000. Then we consider it's a 2. And further I simply copy the same things and paste one by one. Okay, so now put the second third number class. So mainly I put here that 1000, greater than 1000 and less than 2000. Okay, then greater than 500 and less than 1000. And further I simply put here that only one class where elevation less than equal 5000. Okay, and make the another class. And now I put the class value. Suppose it's the 1 2, then it's 3, then 4, and then 5. Okay, so this in this time what happened? So this, it's a low, less than equal 500 meter elevation. It is the high susceptibility of the flood. It's a very high, then medium, very low, then very low. Okay, so now I want to show this result. Simply copy and paste. So further we are just run the code and see what happened about the elevation score. Okay, so now it's working. Just open, yeah, of things. Just in this time I shall simply add the color. 5 class, and in this time here you can see it not calculated the distance from water is not included in this time, you can see. So that's why you can get this type of color. You can see it's not include the elevation in this time. Okay, because I put here the distance not equal to 0, so in this time it not considered. So this type of reason is show as a blank. It's a blank show in here in this time. You can see there is the no data about that about the dem. Okay, so now we are just set the color. So just click on here, and then further okay, elevation. Okay, so you have to open the, okay, so just click on here and click on the plate. Suppose in this time one, it show about that low. Sorry, it is the, okay, 1 2 3. Okay, I have to set the mean and max value also. So just put here the mean 1 and max 5. So now click on run. So now it's working. Okay. So now I set the color. Suppose click on here. So now I set the color. One is show about that the very low. Okay, so one is very low. So just I simply put at the very low same color. Suppose red color, and then I simply then put here suppose two. I want to add here this type of yellow color, and then suppose three. I want to show this type of green color. Four. I want to show this type of paste color. And finally, for that flood, I want to show this type of, it's the high risk of flood. So blue color. So now apply. So now we can get the result based on your. So now we can get this type of thing.
Now you are
Yeah.
now you are right.
Okay. Yeah. So now it will show this type of things. You can see it's the flood.
Yeah, because you see that as I told you, these parts they have had any time when the flood will
Yes.
be
Yes. Yes. So it is a,
here.
okay. So it's for the high risks of flood according to the elevation you can get from here.
Yeah.
So now I simply import these things. So just copy.
But this is for now, just for now,
So in this time it shows
just
what?
for now or something.
Okay. So in this time it's based on the elevation. Okay. Suppose it's for now because in this time there's not much change for the elevation or height from the thing.
It means the data will change. It can be changed anytime.
No, in this time
And
we are using at the NASA SRTM data set because basically you can see we use at this type of data elevation, and this data can be changed, but uh, this data set we can get from the year of 2000. Okay, so that's why this,
2000
yeah.
to
Yeah.
why to now.
So in this time it's a fixed data set for one time.
So I would like to understand the data that we have. What is the last update?
In this time this, okay, so
What
in
is the last update?
this data set is not update because it's a
What is the last update of this data?
okay, let me check. I think this data set is not updated because team data is not updated. Okay, let me check. We can get, yeah, we can see 2020.
Just updated.
Yeah, 2000. Okay.
That's where we can this is where we can find the data for the updates data,
Okay, so for that you have to use
so that we can reflect the reality.
Yeah,
exactly.
yeah, yeah, yeah.
This
Yeah.
20 years, more than 20 years ago.
Yes. So let me check about the suppose Esther data. Esther, it's another DEM data. Esther DEM in Google Earth Engine. Esther global DEM. Let me check about this data. It's this another DEM data, and what is the time period? Okay, released in June 2009. Okay. So this data released in 2009. Okay. Mm-hmm. YouTube format. Okay, to download. Okay. Okay. NASA digital model 2018. Okay, Star Global Digital Model 2018. Okay, so this DEM data is last update in 2018.
It's not possible to have the data elevation data,
Yeah,
the timeline
yeah, possible, but for
elevation
that
data.
we have to. I think we have to buy for the recent data. For that, such as LiDAR dataset. LiDAR dataset. LiDAR dataset where I download it, so I can check it. For I think for the recent, when you want to take for any recent DEM data, then it's a kind of cost, or you have to buy this DEM data. But freely we
Okay.
use such as past year, but present time we have to buy this type of data, and we have to use this type of data. Mhm. So we also see the some top six free LiDAR data set. Mhm. One is the open topography. Okay, use. Okay, so I also show you that I also try to show you the another class how we can easily download this type of present freely. Okay, I think for the present timeline is not possible, but we can take for the 2023 or 2022. These type of things we download and then try to use it in Google Earth Engine platform for getting the present DEM data. Okay, so in this time we can get this type of things, and for only so that's why, so that's the region we are not consider only for the one data set. We are also consider about that precipitation for the present time, NDWI present time, NDVI present time, or TP, this type of things. Suppose NDVI, NDWI, precipitation, or land use, land cover. So these type of things we consider as the present time, and then add with this data for the DEM data, which is not available for the present. Then we are also get the better subsidiary map. Okay, so for but only for the only for the consider only for the DEM data, this map is not accurate because it show about the very past time, year of 2000 DEM data. But when I want to work for the NDVI, NDVI is the present time, NWI is the present time, precipitation is the present time, land use, land cover is the present time. Okay, then we also get the better accuracy of the flood region map. Okay.
So it means the all the data are the relay time,
Yeah, only for the
but
DEM
this
data.
elevation, but only elevation they don't have relay time.
Yes, yes, yes. And I think it's also
So
possible to buy some other sources for the present DEM data. It's possible. But really, we are using the DEM, NASA SRTM or STAR, this type of DEM. Really, we can use. Okay, so we'll
if
try.
you
Yeah.
can if you can get the data the relay time, we have the good overview of
Yes.
what kind of situation is
Yes.
activity.
Okay, so I will
But
inform you.
if you want to change a source of data, where will you click
You can simply click on here. You can see
elevation?
SRTM. It's a NASA SRTM. So basically, this data set
But
I
it's
stored
better.
in
I
here.
think it's better for at the end of each line of variable each line to
Yeah.
put a comment to say this
Okay.
one, because like this, yeah, this one is for data elevation.
Okay.
This
Okay,
one
I use,
for
you can see
like
DEM, 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 yeah, DEM. It's a DEM data. DEM data is mainly digital elevation model data. And SRTM, basically this variable stored this data set in here. You can see NASA SRTM,
You see,
SRTM.
when you write just them it means what? If you maybe I will it will
Okay.
be
Right
yeah.
here, it's a digital patient, whatever, data. Okay, so from here we calculate the elevation, and from the elevation data we also use here the topographic position index, and then we and also you can see the L8. So basically it's a this data set, it's the Landsat image collection we use for the NDVI and LOLC. Okay, two things we try to develop using this data set, and then further we are make the NDVI. Okay, so just in NDVI we
So
calculate.
this one is to add, but first of all we need to have a variable to download.
Yeah, if you want to, we also download this type of things as a raster format image. Okay, suppose this map we downloaded, also distance hazard we can also download it, or this time. Okay, I'll show you the later after completing the full process. Okay, so in this time, so in dvi okay, so in this time we only for the two score we calculate elevation score and distance score we calculate. Okay, two score we can get that for the elevation score this type of region is high risk of flood. Okay, this type of region, a blue color region. Okay, and also you can see for the digital distance, for the distance we can get this type of things, this type of blue color identify about the high risk about that. Okay, so now suppose I talk about the another factor for flood. Suppose I want to talk for that elevation. I want to talk suppose topographic position index. It's very important, and we already calculated the topographic position index. You can see TPI. Okay, so topographic position index in this term we consider, and then make the total 5 class. In this time, okay, so let's go. I write the code. Okay, so if you want to also add the color, suppose I add the color for that topographic position index. So I use the plated. And what is the topographic position index? So mainly, you can see the topographic position index. When I can get that negative value identify about the valley or gully bottom. Okay. So and positive value it show about the hilly region or hill area, and zero or near to the zero it show about the continuous slope or flat area. So now I just simply put this color according to this thing. Suppose for the negative value I need to show this type of blue color. Then suppose use this type of color. Then suppose use here this type of color. Suppose I use here this type of color. Okay. So now I apply. So now I can get this type of things here. You can see. Sorry, we have to stress 98%. Then it reflects better, and we can get. So now I apply. Okay. So in this time we can get this type of things you can see. So mainly from this map we can identify this type of region is the high topographic value. Okay, topographic position is the high, and this type of region is the low position about the topographic. So it's the negative pixel. So in this time this type of region is the high risk of flood because it's a valley or bottom of the valley. Okay, so here you can see we can get the get this TPI 0.6. Okay, near to the zero. Okay, near to the zero. So mainly near to the zero is the flat or near continuous slope, and mainly flat area is also flat plane. Okay, so now let's check about that. We just make the classification for the TPI score. So let's go. So in this time I just take a variable. I talk about the topographic position score. When we take a variable, okay. Okay, suppose I put the variable name is that TPI for. In this TPI score, first of all, I don't consider any kind of distance. Okay, don't consider any kind of distance. So for that, I simply call the TPI. So this is my TPI, and paste here. And at the update, it marks distance to water not equal to 0. So distance to water, you can see distance to water, yeah, distance not equal to 0. Just put here the distance not equal to 0. So now it I just simply put the some condition. So just use a function, where TPI was greater than. When I can get the TPI is greater than, suppose TPI is greater than, in this way we can get this type of value TPI, you can see. So just simply consider, basically it's the high value, it's a, I can see this type of high value identify about the hilly region. So just I simply paste in here greater than, okay, we take only for the integer value, greater than, and I put this one. Okay, suppose when I can get the high value, it means that this region is very low susceptibility, one. Okay, just I put here the one, and then put the other condition. Suppose just use here the where function and call the TPI, I make the total 5 class. Okay, suppose TPI in this time, suppose TPI dot greater than, suppose greater than 1000 and TPI less than equal, suppose 30. Okay, so it's another class, suppose 2. So now I simply copy these things from here and paste one by one. So 5 class. So 2, 3, 4, and 5. So now I put here. So just these things one, then I put here that suppose greater than 500 and less than equal, suppose 1000. It consider as a 3 number class. Then put here that suppose 100 and less than equal, suppose 500. It's a put here the 4 number class. And finally I consider all of those negative pixel values. Suppose put here that less than equal, such as less than equal, I put here that for the elevation, suppose less than equal minus 100. Okay, minus 100. And then I put here these things and put the class name, suppose class number 5. So now further I just check this result. So such as I simply add here, suppose map dot add layer and call this TPI score, simply copy and paste here and put here that mean, it will be start from that -1, sorry, 1, and max up to your 5. Okay, so now click run, and now I set the color from my here. Then we can easily identify, we can get the wrong in here. We have to use here the uppercase TPI, simply copy and use here the uppercase TPI. Yeah, and click run. Now open this. Okay, I have to put the layer name. This layer name is mainly is the elevation. Okay, you can get this type of things, you can see for the TPI. So now we set the color. then you can get the better map about the TPI score. So just click on here, and mainly for that in this time one is the high. Okay, so one is the very low flood. Okay, so just I put here the low flood as a red color. Okay, then I put here this type of yellow color. Then at this three, suppose this type of green color. Then four, suppose I want to put this type of paste color. And for the flat I want to use suppose this type of blue color. Okay, so it is the low risk, it is the high risk of flat blue color. Okay, so now apply. So now you can get the result depends on TPI or topographic position index. It working? Okay, done. Okay, okay, so now we can get this type of things from here. We can get suppose this type of blue color identify about that flood risk is high, and this type of great color identify about that your low risk, and this type of things about the very low we can get. Okay, so it create the topographic position index, and based on the score which I set in here. So now further just simply import these things for the TPI and simply copy and then add in here. Put this name, suppose it's a topographic TPI score. So now we also get the TPI score. Further we talk about the NDVI, NDWI and precipitation. After that it will be finished, and then we are just applying the ASP method and then make the final map. Okay, so now it will work. So let's go.
I think we did a lot of things, but I'm confusing now.
Yeah.
Which kind of because we need to have also the legend. How we can have the legend? How we can know? We had a lot of maps. So
Yeah.
which maps we need to consider exactly?
Okay, so in this time we are just using the final map. In this time, basically, this type of factor TPI or elevation or distance hazard. So this type of map we are make the combine. Okay, all of this layer we are just make the combine or merge together, and then
So
further.
if you combine, if you combine, what kind of map you will have? The final map you will have
Yeah, we
after
can get the
combining
final hazard map, final flood hazard
this
map,
one.
final
This
flood
one?
risk map,
This map is the final.
final hazard map. Mainly, what's our target? Our target is that we find out the flood risk map. Okay, and we are just use this type of map such as distance to road map, then elevation score, TPI score, or NDVI score, NDWI score. This type of score we are use, and then use this ASP method and calculated the final hazard map. And this is our final product for the final hazard map or final risk map of flood. In this type of thing as a factor, it will be work as a factor for flood. Okay, it's not our final map. Our final map create later. After creating all of those score, then we are just combine all of those suppose all of those map we are combine, and then we are create the final flood risk map. Okay?
Yeah, that's why for me, I have a question. The question is, for now, this is the last map that we need to use, and this map is the results of the combination of all layers.
No, it's
Right?
not. It's not. It's not. It's only for the TPI, mainly topographic position. Okay. So after calculating all of those others, suppose NDWI, NDVI, when I our precipitation, we'll just make the class, mainly total 5 class. So in this time, we'll just only work for the 3 map. Okay, TPI, we make the 5 class, elevation, create the 5 class, distance, hazard score, create the 5 class. So now make the 5 class for precipitation, make the 5 class for NDWI, make the 5 class for NDVI. Okay, mainly 5 class, 1, 2, 3, 4, 5. And what is the one? One is mainly your low risk, very low risk. 2 is the low, 3 is the medium, 4 is the high, 5 is the very high risks. You can see all of those things. We create this type of 1, 2, 3, 4, 5. Also, you can see we create the 1, 2, 3, 4, 5. 5. Also, you can see we create the 1, 2, 3, 4, 5. Okay. And now, finally, when we complete all of those things, we are just merge and combine and then make the final hazard map of this region based on this type of factor. Okay.
No, it's not okay. The explication is not okay because my for
For
my
my
understanding,
understanding,
this
this
map
map
is
is
the
the
result
result
of
of
the
the
combination
combination
of
of
all
all
maps,
maps,
all
all
layers,
layers,
right?
right?
No, no, this map is only for the TPI. You can say TPI score. It's the TPI score. It's the elevation score. It's
Means
the
if
hello.
give me just 1 minute, please. Sorry.
Okay, okay.
Uh, okay,
Okay,
for
for
my
my
understanding,
understanding,
I
I
will
will
say
say
for
for
my
my
understanding,
understanding,
this
this
map
map
is the result
results
of
of
the
the
combination
combination
of
of
all
all
layers,
layers,
No,
right?
right?
no, no.
Uh,
This result is only for the topographic position index.
But why you check? Why you check every
In this
all
time,
maps?
in this time,
You check.
yeah,
Yeah.
in this time we have to create all map. Suppose precipitation or elevation or TPI or distance to road. We create the total 5 class. Okay,
Okay.
5 class. In this time I make the 5 class for TPI. Before I make the 5 class for elevation. Before I make the 5 class for distance. Okay,
This one I get. So my problem is to get the map of floods risk.
matrix.
Which we okay we have those layers. So which layers we need to consider? All we need to type all layers or
All
only
layers.
one?
We consider all of those layers in our final result.
Okay. So
Suppose-
the final results, the
Yeah.
final results is our floods risk.
Yes. In this time, it's just as a factor of float. Okay? Final result, we can easily get, suppose all of those things we try to combine. You can see this is the previous code. Okay. So in this time, we can see for the flood hazard. For the flood hazard, all of those score, suppose distance score, TPI score, vegetation score, weight score, elevation score, all of those score is simply add. Okay, and then
That's why we did it. Why this is our code? Is it?
yeah, it's available for the other region, but for the new region we have to check the value because this type of value is not fixed. Okay, so it's different for the different region have different. Suppose same region is not the same elevation or same height, same resolution is not the same precipitation. Okay, so that's why
Please, I'm confusing. This code is our code or not?
it's not our code.
Is it the code?
No.
Is it the code that we are working on it?
Yeah, we can working on
Because
this.
here, yes, here I didn't see the floats, but to another code I see the floats. So
Another code. It's another. It's our code. Okay.
yes, what is the float here? This one I didn't see the float race.
Yeah, we step by step we go to the float. Okay, because it's I already developed these things in here, but we are step by step we go this in our code. We add all of those things one by one. Okay, understand it. Okay, so in this time we talk about the topo is TPI score. Okay, and further we talk about the suppose NDVI score. Okay, for the NDVI we have to create the score of NDVI. So mainly total 5 class.
So in the code that you showed me, I saw everything, the vegetation, I saw the floats, but here I didn't see the floats.
We write the code step by step, one by one. Okay, so it's already completed code for the other region. But in this time, we write the new code for your study area. Okay, so in this time we talk about the vegetation score. Okay, and we already make the map of NDVI. You can see we already make the map of
For
NDVI.
this one, no. For me, I would like to see the floats as a code here in this our study area.
Yeah, we can make the. Okay, you can see here. Okay, you can see here. So before the
This
float,
is not our. Is it our? Is it the same?
yeah, same code, but in this time,
Okay.
in this time we write the code for other region. Okay, for that's why in this time this type of value is not same. So that's why you can see in this time they are put here the distance score 3000, 4000, 2000, 3000, 1000. But in this time you can see what I put in here in our distance score. We
But
put
you
here
can just copy and paste and you will just change. It will be easy for me to understand and to know instead of type like this. If you copy and paste and you explain line by line, it's easy.
okay, just a minute. Okay. Then it will save our time.
And
Suppose I simply copy these things from here, vegetation score, and we already make the NDVI map. Okay, so just paste here. Right. So in this time vegetation, we already make the map of NDVI. So these are NDVI map. And you can see here my variable of ndvi. This is my ndvi. Okay, so now I just make the class of ndvi, such as here you can see mainly high vegetation, where I can get the, suppose I check here for your study area, simply click on here. Here you can get what is the high vegetation of your study area. So just I simply straight 98%. So now it automatically show about the low and high ndvi value working. Yeah, see it working, and it show the high and low value. So according to this high and low value, we change it this type of value. We can get the 0.7, but it shows, so I simply change this. Suppose 0.7 is for my high 0.7, and I consider it is the one because high vegetation is the lowest risk of flood. Okay, and then I simply put here the second class, suppose 0.6 to 0.7, then put here that suppose 0.5, 0.7, then put here that suppose 0.4 to 0.5, and I consider all of less than suppose 0.3, all of those 0.3. And now I just create the total 5 class, so it's not needed in this time. Okay, so remove that. And okay, I said it's also not need. So now click to run. In this time you can see it show about the vegetation score, total 5 class. Okay, distance not equal to water. Okay, we have to use these things, distance, copy, and use the same variable name in here which I write in my code. So now click run. So now it create the map for vegetation hazard score. And further we talk about that, suppose NWI, mainly we calculate the weight score, okay, from the NWI. So just simply copy, then further paste here the weight score, weight score. Okay, so add the color about that. Suppose click on here. Suppose high, I want to add this type of yellow, green, red color. Or the low, then sorry, very low, then low, then it's a medium, then and very high of flood. So now I apply. So now we can get the result based on vegetation score. Okay, red color identify about the high flood risks, and sorry, red color low, and blue is the high. So now I can get this type of things here. You can see basically this result show depends on the vegetation score. Okay, where is the high vegetation? It show as a low risk of flood. Where is the low vegetation? It show as a high risk of flood as a blue color. We can get this type of things region. So just I simply import these things and then copy, and then paste here. Now further weight square. So basically we can open the NWI map. So here you can see the NWI. Find out the NWI, click on here to find out the value. In this time here you can see it create the serial look like that 5 4, 3, 2, 1. Okay. 5 is, what is the 5? Mainly 5 is that 5 is the high risk. Okay. So when I can get the high value of the positive value of NDWI, it is that 0.4. I simply put in here 0.4, greater than 0.4, and further I simply put here that suppose 0.4 greater than 0.4 and less than suppose 0.6. Okay, it's the another things 0.4 to 0.6. Then in the way greater than negative, suppose 0.2, 0.2, we can take another class 0.6 to get less than 0.3. So in this time 5, 4, 3, 2, 1. And further it's not need, I simply remove that. Okay, it will not remove that. So just I simply set the color for 5 class of color. So now click run. In this time we can get the result based on the, okay, so we have to use the same variable. Okay, run. So now further click on here and set the color plated. So for the one is the uh Lorix. Just I use this type of color. And high Rix, I need to show this type of blue color. Apply. Just after doing these things, we are just working for the flat hazard. Mainly in this time we add all of those layer together. So simply copy. Get this type of color. So import that and paste here. It's our flat hazard. And then further we just simply copy here. Okay. And now for the distance score, TPI score, you have to use the same variable name TPI score. Simply copy and paste here. Then we have to use at the base score. Simply copy and paste here. Weight score, elevation score. You can see the name about that elevation score. Simply copy and paste here. Okay, and rename it the flat hazard. So now it show the flat hazard. In this time here you can see total we can get the 1, 2, 3, 4, 5. Okay, we can get the total 5 factor we consider in here and then find out we can get. So now I just simply remove these things, it's not need. So now click the run. Okay, we can get this type of flat hazard map. Okay, suppose in this time I just simply click on here and then okay, we are just make the class about that. Suppose that 5 clause I create from here. So for doing this thing, just simply copy from here and paste. So greater than 15, we can take about that. Yeah. So 1 to 5 class. Now run. This is the final layer which we create in here with the flood hazard score. Okay, so it will be loaded. You can see. So further, we are just add the color. Click on here. And in this time, it combine all of those other factor which I created already. Okay. So now click the plated. For the one is mainly low risk. So just put the red color, then yellow color, then suppose green color, then suppose put at this type of things, and finally use that this type of. So now apply. So now it create total 5 class of the flood risks. So red can identify about that low risks, blue can identify about the high risks. You get this type of things you can see for whole area. And further I just simply import and copy the flood hazard risks color and paste here. So it's our final output we generate in here. And in this time we can get the all of those layer combined, and here you can see the map look like that, and it show this type of yellow the red color. It is the low risk of flood, and this type of thing is the high risk of the flood, this type of, and it's a medium. Okay, this type of serial suppose which I already create in here. Yeah, so very low. So very low mainly show about this type of red color. Okay, this type of red can identify about the very low, and this type of yellow color, you can see the yellow color, it show about the low. This type of green color identify about that mainly medium. Paste color identify about this type of color is a very high, and this type of blue color identify about the very high. Okay, so now if you want, you can set the color or legend about this map and represent this map as a flood hazard map. Okay, so in this time we are just consider only for this type of factor: wetness hazard score, vegetation hazard score, TPI hazard score, elevation hazard score, distance hazard score. Total 5 factor we consider and create this type of hazard flood risk map. And so now we add the legend. So for the legend, just I simply copy the same code from here and then add it. Simply copy and then paste here for the legend. So now click run. So you can get the rainbow index. Okay, so in this time, I simply check about the rainbow color. Okay, so in this time, they are put this type of color. Just it's a legend color. Okay, so now click run. In this time, we are user. You can see. Okay, so we are user. Let me check my color. Okay, we use at the red color. So if you want, you can simply click on here and copy this color because I want to use the same legend of my color. Copy and paste here. So one is mainly 1, 2, 3, 4, 5. One is represented what? One is represented very low. Okay, so very low is the blue. So just okay. So I put here the red. It's a very high, and then put here the yellow. Yellow is mainly this color. I simply copy and put here this yellow, and then put here the green. So basically this color. I simply copy and paste here. Then use here this color. Mainly it's a cyan color. So just simply copy and paste here. And finally blue color. We copy and paste here. So now click run. So now it's set with our color and also set with our legend. Okay, healthy flat bricks we can get, and further we can easily represent it as a map. Click on here. Correct. Click other layer. Yes, so now I can see it show this result. Further, if you want, you can simply download this raster as a TIFF format. And further, you can also make the map using ArcMap software for your presentation work. Okay. When you want to use this code for other place, you must change the value, such as thresholding value or classified value for elevation, vegetation, NEWI, weight score, TPI score. Then this code work perfect, and we can get the perfect map. Otherwise, it not work well. Okay. So in this time we can get.
So
Yeah, please.
it means each location
Yeah. For each
have
location, we have to change the value. Such as this type of value, which I set in here for the score value. This type of score value you have to change. Suppose distance score because it's not same for all time. Distance value also you can see the about your elevation value we have to change also. TPI value we have to change also. Actually,
so
based on our study area.
how will know how to change this value.
Okay, I show you that when I write the code, you can check it how we can do that. Simply click on here. Suppose you simply open the map. Suppose elevation. Suppose elevation is you can simply open the map for elevation. Okay, and then further just simply check what's the highest value of the elevation. Simply click on here and you can see click on the custom 98%. Suppose now we can get this value. We can get the value. Suppose you can see greater than 200 300. It's your high value about that. You can simply put this value in here, and further you can simply make the classification between this class. You are just make the classification total 5 class according to yourself. Suppose greater than, suppose when I put the greater than 2834, it's the high one. Suppose then according, suppose you are just show this value and mixing its minimum maximum. So just you show this value, and then you are just make the total 5 class about this value. Just make the 5 class for elevation, NDVI, or precipitation, anything. Suppose
So
TPI score, all of those score, you create that. You can also use this code in other place, but we cannot get the better result if you don't change this type of value, because this type of value will be changed based on your study area. Okay.
So if you need to update this kind of maps,
Yeah.
what we can do?
For the update for when you want to apply the new region for any other study area, So for that you
No,
are
no,
Not
not
area,
area,
the
the
same
same
area
area
for
for
the
the
same
same
country,
country,
like
like
for the
for the
same
same
studying
studying
area,
area,
update
but
but
time, update
data
time.
we need to
You have
apply
to,
try
to
yeah.
to
update the
update
data.
the
For that you have
The
to
data.
update your satellite image. Mainly you can see we can take the image for 2023 01, and also update the precipitation data. You can also update. You can also update your mainly freely if you want to update. If you buy any DEM data, suppose other sources for the update DEM data, then you can also use it for the TPI or elevation. You can also use it for, and you can also update it. Okay, if you want, you can also add the other thing is the land use land cover, because it's the update information. For suppose a present time, you are just make the land use land cover map, and also consider this map in here. In this time we are not use the land use land cover. You can see we are not put the land use land cover in this time. We are not considered. Okay, so it also possible if you want to add the land use land cover map. And okay, so further I also try to show you that how we can add the land use land cover map, because in this time I not create this region for land use land cover map. So further, if you are interested, I also try to show you that. So basically for the updating, when you need, you can update this type of things. For the update information you can add, suppose update, you can add for one, for suppose rainfall, it can be updated. You can update it the LULC, you can update it the NDVI, NDWI, you can update. You can update it also. Suppose basically this type of things we can update: rainfall, land use land cover, NDVI, NDWI. And finally, if you have other sources, suppose you buy any DEM data, it also possible to update the DEM. But this DEM data we have to buy for updating. And other things, rainfall, land use land cover, NDVI, NDWI, we can
so
So
easily get freely.
how can use this? How can use just keep like this? But how can I use it from my sides? Just
Okay, so for doing this thing, suppose first of all you just simply change the ROI. Okay, you can simply import your study area, or normally suppose, okay, I'll show you that. Suppose
no,
no,
no.
no.
If you share,
If
you
you
share
share
with
with
me
me
this,
this,
how
how
can
can
I
I
use
use
it
it
here?
here?
okay, you just simply okay, this is the code.
Even
Okay, so you just simply open, simply remove this previous ROI. Okay, it's my study area which you send me. You simply remove this ROI, and then further just simply open the new ROI. Suppose new boundary. Suppose I want to work for the coastal chef, this area. Suppose simply click on here. You can see it will be updated. Okay, and then remove the previous ROI. Okay, simply click on here and delete it. Okay, and then put this name as the ROI. After removing this ROI, put this name as the ROI. Okay, this new variable, just put the ROI, click to the run, and further you just simply check this type of score, this type of value. Suppose this type value, this value, you just simply check this type of value according to your study area. Okay, all of those value, and run this code. I hope it will work, there is no problem. Okay, for any region, just simply,
No,
no,
for
from
my
my
side,
side,
for
yeah,
from
my
my
side
side
here.
here.
yeah, for your set, simply remove the previous ROI. Suppose, okay, just I simply take a new link about that, and suppose I open this new tab. Open. Okay, just open, and then further I change this ROI. Okay, okay, so you can see it will be open. Just open this code.
Try to send
Send
me
me
this
this
link.
link.
I
I
would
would
Okay,
want
to
to
check
check
I
if
send
it
if
you
is
it's
the,
possible
possible
for
for
me
me
to
to
open
open
it
it
here.
here.
I send you, I send you the WhatsApp.
So
So
I
I
don't know
don't know
if
if
it
it
is
is
possible
possible
also
also
to
to
use
use
this
this
like a
like a
shape
shape
file,
file,
no,
no,
Yeah,
in
shapefile.
PBIS
PBIS
or
or
something
something
Yeah,
like
like
yeah,
this.
this.
any shapefile. You just simply import the shapefile, and then further rename as the ROI, and it will work. This the code is, try to open, and then check the result. Okay, you can see it will be open in here from my another code. I simply remove the previous ROI. Remove. And I already imported the another shape file. Suppose I want to work for that coastal area. Suppose I just simply find out my shape file for coastal, okay, coastal shape, and I put this name as the ROI. So just use here ROI. Okay. So now further I just click to the run. In this time you can see we can get the result for our coastal area or other shape file. But this result is not perfect because I need to change the all of those score for that elevation. I need to change the score for DEM. I need to change the score for NDVI. These type of things I need to change. Then we can get the perfect flood risk map. In this time it worked, but this result is not better or better validated result. We did not get from here. So just I simply open. Working, get opening. Yeah, you can see it open. In this time you can see we can get this type of map. It show all of those region. It's a very then I can get this type of map. When I change this type of score, then we are also get the better map.
So this is the final map.
Yes, it's a final hazard map. If you want, you can also export it. Suppose you just simply export, just use here for exporting, just use this code, and then you can easily make the map using the
For the data, so for this final map, we use a lot of the data, a lot of data
yes,
sources.
yes. And I simply use there this function export is to drive, and then just export this flood risk map from here, and then we can easily make the map using ArcMap or QGIS software for the better map. So just I put here the image. Image mainly I need to download from the flood wizard Discord. Simply copy and paste. The description I put the any name. Suppose I put this name as a wizard map folder. You can put any folder name. Suppose I put the name is a flood. It's not needed in this time. Region is our study area. So mainly it's a RY. L is the resolution. So mainly in this time we are just using at that 30 meter. And then further it's not need. I will remove that. And for the big region, we are just using the max pixel value is a 1E13. So now just simply it's not need. So now click to run. So now from here you can easily export this flat hazard map as a TIFF format. And further we are also working with ArcMap or QGIS software for preparation of our map for the project work. We can easily represent the beautiful map. Okay. You can see you're running hazard map. Click the run. So now it will be stored in your Google Drive. After downloading the Google Drive, just make the map in ArcMap software. Okay.
Yeah, send me the last
Okay. So just I say, I take the new link. Yeah. So this is the final code for that. Also add this export option. Okay, let me. Okay, what is that? Okay, so you can get this code. This project isn't open. Why? Okay, so I also send you the recording video class. You also try to check again
Oh,
and further
can you
Can you
share
share
with
with
me
me
this
this
the map
the map
that
that
you
you
download?
download?